Hello and welcome back to the CCENT journey with me, Ryan, and in this section we're going to look at unboxing and setting up a Cisco. For those who don't know, you can contact me here on YouTube, on LinkedIn or Twitter. Okay, so we're going to jump straight into actually quickly unboxing the Cisco, powering it on and plugging it in using the console port. Apologies for the sound and video quality, it was recorded on my phone, but I think it's good enough to just at least give you a feel of what it is I'm actually going to be plugging into the PC. Okay, so here we are. We have a brand new Cisco A87 VAG, which is called the VAG. There it is, it's the 4G and also has ADSL or VDSL WAN output here. It has a 4-port switch module built into it, and of course these bits over here are for the antennas for 4G or 3G capability, and then just under here is where you would pop in your SIM to actually give you some sort of cellular signal. So the box is brand new, it's just been unpackaged. It came with a couple of Ethernet cables, it came with the old style console cable. The one we'll be using is actually already plugged in. It's a USB to RJ45, the one we didn't talk about previously. So we're just literally going to power this guy up, plug this into the console port, and we'll see what we're presented with. We're going to use a secure CRT as our terminal emulator, and we're just going to plug that in and get set up. Apologies, one thing I should have said there was actually a terminal client, not a terminal emulator. So here we are, we're actually loaded up a secure CRT and we're going to connect to the console of that A87 and then do the initial setup. Now before I can do that, since I'm using a USB to serial cable, I need to first of all establish which COM port has been assigned to the USB port. The way we do this is looking at the device manager within the control panel. So I'll bring up the control panel and we'll have a look there. So here's the control panel, and then from here we're going to go into device manager. And then from the device manager, if we click on COM, you can see here I have the USB serial port and it's been given the COM3. Now the reason that's important is because when we go and actually connect using the serial, we actually need to use COM3. So it's already given us the it's actually identified it's a USB serial, which is great, but some terminal clients don't do that, so it's important you have an ability to find out the COM port that's been assigned. If you know a better way of doing it instead of using device manager, please let me know. We need to set the configuration for the console port, and in this case the actual settings are as so. So normally again this is detected and it will vary depending on the terminal client, but as long as you remember it's 9600, 8, 9 and 1 for the different stop bits and data bits and so forth, just as shown here, and you're on the right COM port, then when you hit connect you should actually be presented with something. Now you can see at the top I've got this sort of green tick that indicates that something's responding to me on that port, and if I press enter, there you go, you can see I'm now presented with what looks to be the initial configuration for this A87. Now along the top you actually see that we have this banner up here, and it says it's the Cisco Configuration Professional, in brackets Cisco CP, and this is installed on the device and requires one-time use of the username Cisco with the password Cisco. These default credentials have the privilege level 15. So ultimately what this means is there's a bit of software installed on the Cisco, albeit it's optional whether we want to use it or not, but this software allows us to pre-configure the Cisco using a GUI. And if you want to know more about this type of GUI, which is a graphical user interface, you can go to the link www.cisco.com/go/Cisco CP, and if we go to that, it's ultimately a GUI to help set up and to automate some of the network tasks that you would do on a device, but this is something that's not inside the CCENT scope and therefore something I will not go over as part of this configuration. So what is it I'm going to go over? I think what we'll do is we'll get back into the console of the box, and we will actually delete the configuration that's there today after we inspect what is there, and then we'll go ahead and set up an interface with an IP address. No shut that interface, so when we plug something in it will actually come up, and then we'll go ahead and we'll enable telnet on the device so we can telnet into it for remote management. We'll do that to begin with, and then we'll see how much time we've got left. What we need to also think about when we're at this stage is understanding NVRAM, the startup config, running config, flash, and iOS management, how we would upgrade and downgrade the particularly iOS or the firmware, if you like, of the Cisco box. Now all of that can be done kind of much better with physical boxes than it can be in Packet Tracer or GNS3, because you don't really have much control over the flash and what's going on there. One of the things it says for us to do straight away is to change the default username and password to log onto the device, because at the moment it's Cisco. So let's do two things very, very quickly. Let's change the host name of the box. At the moment it's your name. Let's change the host name to router. And then let's change the username. Let's give it a new one. And if we pressed question mark here, ask us for the name. Let's say it's actually Ryan, all lowercase. And it asks us for a bunch of additional options here. But I'm going to give it the privilege level of 15. And I'm going to give it the password, which I don't want to encrypt. And we'll give it the password of something very simple. Now the reason I've done such a simple password is because obviously this is not going to be connected to a public network, so we can give it something silly like this, but it's just something as default, so the Cisco itself stops moaning. If we now log on, let's check that that username actually works. So it was Ryan, lowercase, and hello123, lowercase, and it puts you back into the box. So I wanted to do that because the Cisco CP, as you can see here, it puts a one-time password on there of Cisco. So if I log on and then get timeout during this video, I would have to actually reboot with the default configuration on, because it is a one-time use password. Not going to talk too much about that because again it's outside the CCENT scope, but let's have a look at what this router is currently being set up with. So to see the entire configuration, we do show us the running configuration. So this is the live configuration on the Cisco right now. And obviously it's going to pass that and give us the output. Now you can see all of this stuff here are actually banners, and these banners were to inform us both prior logging on and then after logging on. It tells us again to change our details, and these are just banners at the Cisco display. We can see here's the VTY line, something we talked about very briefly recently, and you can see that we've also got an access class of 23. So we know from our previous ACL video that access class 23 means that there's an access list of number 23, and it's protecting inbound on the VTY. So if we actually go up, we might be able to have a look at what that access list is actually doing. And then we also have, here it is here. So it's actually blocking, sorry, that's not it, it's here. This is actually to make sure that HTTP access is also blocked using this access list of 23, and you can see it's permitting just a small range, well actually it's relatively big range there, 128 IPs, 126 usable inside the range of 10, 10, 10, 0, and that'd be a /25. And then here you can see there's a VLAN interface that's been set up. The VLAN interface has been given the first usable IP, and I assume there's some sort of pool. Yeah, there's a DHCP pool, again something else we've talked about. So the way this has been set up initially is you have a bunch of interfaces all configured with no VLAN. So we know that by default these are switch ports, and as such they become VLAN 1. So if you plug it into Fast Ethernet 0, 1, 2 or 3, you're going to get an IP address from DHCP inside VLAN 1, and then you can browse to the HTTP of the device, authenticate using your local credentials. So that'd be the credentials that I've just set up here, and then that's how you would access the CP, the Cisco CP, that's actually been installed on the device, but we're going to do it all through the CLI. So what I do want to do is erase all of this configuration. So to erase the configuration, we do the erase startup config, and now actually went away and I got timed out. So because I got timed out, thankfully we created that username, local username, so I didn't have to reboot the box. And now we're actually going to erase the startup configuration by doing erase startup configuration. And the idea behind this is when we actually go to reboot the box by saying reload, the Cisco itself will now obviously power off, power on, as requested by Ryan on the console through the reload command. As it goes through its procedure of bringing the Cisco back up, it's going to look at the startup configuration, which is obviously the configuration it requires to boot, and notice that the startup configuration is completely empty and therefore boot the default. So we can see here it's actually trying to initialize the ROMMON mode. So this is the mode that the router will go into, and inside this it will then uncompress the image from flash and it will do a few hardware checks prior fully booting up the Cisco. ROMMON mode is also somewhere where you do your password recovery, or if your flash becomes corrupt, like your iOS becomes corrupt, it will put you into ROMMON mode. So we can see just by looking at this what platform. It's like I said, it's an 887 VAG 4G. How much RAM we have available. It's important to know how much RAM is available because obviously as you do iOS updates over time, so maybe there's like a bug or something and you want to update the iOS, you need to make sure that your particular box has enough RAM to actually boot the iOS and enough flash storage to actually hold that iOS image. So it's actually doing that test. So like I said, it initialized the ROMMON mode. It now looks at the images it has available, which different firmware or iOS images, and it will test the image, and providing that the image tests successfully, it will then boot into the iOS. Now at this point you can have multiple iOSs on your flash and you can have different ones booting, but providing that this particular system only has one image on, it's obviously going to boot that default image. We can see once it's done the test, it will then start decompressing the image, and once it says OK and the image is fully decompressed, it will then try to actually start booting it. And then once the image is fully booted, obviously it will try to boot the configuration that goes along with it. So it's telling us again what versions it's running, what series of Cisco, so it's part of the 800 series. And then it comes up with all the interfaces that are actually available. So we have a DSL controller. So again, that could be both for the Ethernet or it could be used for the ATM. So PPPoA, PPPoE. We have 4 fast Ethernet interfaces, which is the switch. And then we have those terminal lines. We have a VPN module and a cellular interface, which was those 4G, 3G that I showed you just now. Tells you how much of non-volatile NVRAM we have. So the NVRAM is where the startup configuration and running configuration is stored initially. Well, actually the startup configuration is stored there, then obviously it's reloading into the running configuration, which is then part of RAM. Now, what this is doing here, and I think this would continue to come up depending on the make and model, but you notice this IP address, 255.255.255.255. We know that's the layer 3 broadcast, and what it's doing is it's actually trying to broadcast out of the fast Ethernet interfaces on VLAN 1 because they're switch ports. It's trying to actually determine whether someone on the network has these files, so it's able to set itself up. It doesn't, and instead it comes up with, would you like to enter the initial configuration dialog? Now, this here is what you would normally see on the Ciscos. So if you went and bought a Cisco off eBay, unless you buy a very new one, like this particular box, you're more likely not to see the Cisco CP configuration that we just wiped, but instead you'll see something like this that says, would you like to enter the initial configuration? Here we're going to say no. If you say yes to this, it will take you through configuring some of the interfaces, configuring a management VLAN, no shutting the interfaces, and so forth. But here we're just going to say no, and then it will continue to actually boot the configuration and show me what is actually being configured. And you can see here that it's still trying to resolve that broadcast there. So it's trying to reach something on the network. And if we press enter a few times, show run now, you can see that we have just some blank interfaces, no IP address, no DHCP, and this is kind of what you would expect really. The Cisco CP and the initial configuration that's on the box, like I said, that's as you unbox it, that's what you get. But normally this is what you would see if the Cisco itself doesn't come with that Cisco CP pre-configured. So like I said, what we're going to do is configure first of all an interface. Now because this is a switch, we need to put all the layer 3 capability on a VLAN. So we're going to configure VLAN, let's say VLAN 10. So first things first, let's create VLAN 10. And then we can go to the VLAN 10 interface and set an IP. We give it a /24 192.168.0.0/24 with the 1 in that range being the router, but any IP in this /24 can be put on this VLAN 10 interface. And then we're going to no shut to bring the VLAN up, or the VLAN interface up, which is also called the SVI, the switched virtual interface. If we do the show VLAN switch, now the reason it's show VLAN switch is because this particular make and model is actually a router with a switch capability. That's why you have the show VLAN dash switch instead of the show VLAN, which you'd have on a switch or a show VLAN brief. So here you can see VLAN 10 has been created. There's no ports inside it, so let's put a port in there. Let's make it an access port. And then let's put VLAN 10 inside that port, and then ensure that it's no shut. Now normally by default the switch ports are in a no shut state, so we can confirm that by doing the show IP interface brief. We can see that all the ports are in an up state, and they're down state, and they're down here because nothing is actually plugged into them. We can see VLAN 10 is down, and the reason it's down is because it's not been assigned to any ports that are in the up state. So as soon as I plug something into Fast Ethernet 0, I would expect the port to go up, and because VLAN 10 is configured on Fast Ethernet 0, I also would expect this to come up. So what we're going to do now is configure the telnet. Now if you remember in the previous video, we've not gone into telnet in too much depth. We need a kind of a later video to capture the configuration that we're going to put together for telnet. But we had to put in a enable secret, because if we didn't put this in, when you actually telnet to the box, it refuses access. So here we need to create a password. Let's call it Cisco. And now we can actually enable the VTY configuration. So line VTY 0 to 4. So that means that we can have multiple people connecting to this, one to each VTY line. And let's say log on or login is now enabled. But it's obviously, it says here, as you can see, it does it multiple times because of how many VTY lines I've done. Login is disabled on these lines until a password is set. So you can set the password before you do login and you don't get that message, but as long as they're both set, it doesn't really matter which order you do it in. So password, let's do it again, Cisco, just like our enable secret. So we have the VTY, we have it log on, we have a password, we have the enable secret, we have an interface configured, which is a VLAN, then attached to Fast Ethernet 0. And now hopefully what we should get is when we plug into Fast Ethernet 0, we should better give ourselves an IP address inside the 192.168.0.0/24 network and see if we can actually telnet into it. So I've just plugged in Fast Ethernet 0, and there you go, it's come to a up state. Show IP interface brief now shows it in a up state. Notice VLAN 10 is still down, so VLAN 10 will take a while, or the router will take a while to realize that a port inside VLAN 10 is now become available, and because of that it then becomes up in itself. So let's give it a few more moments. If it takes a while to come up, it might be something behind the scenes like spanning tree, because remember, Fast Ethernet 0 to 3 are actually switch ports, and therefore they have to run a loop prevention technology called spanning tree, which is outside the scope of the CCENT. But we can see now we've got the syslog to say VLAN 10 is now up. So I'm going to go ahead and configure an IP address on my local PC inside the 192.168 IP range. So let's do that on the control panel. On the control panel, network and sharing, adapter settings, go to the Ethernet port, and we're going to again set the IP address statically because we've not set up DHCP on the Cisco. Let's just give myself .2 and of course point it towards the Cisco. We're not too bothered about DNS for now. So now I'm part of this particular subnet, and we're going to see if we can actually telnet to the box. So from our terminal client again, we're going to go File, Quick Connect. This time we're going to select telnet, and we're going to type in the IP address of VLAN 10, and let's see if we're successful. So straight away we have the remote system refused the connection. So now we need to identify why that's been refused. So let's just have a look at the configuration quickly. So do we know why? Something we've not covered in depth yet. Maybe you've read it in a Cisco book, but you can see, looking at the configuration in front of me, there's actually something preventing me from logging on. Any ideas looking at that? There's actually something inside the VTY line. And it's actually this here, transport input none. The transport input allows you to actually lock down the VTY to different configuration like SSH or telnet. None obviously means none. So in this case we can say we want to be able to telnet or SSH, or we want to be able to do everything. So let's type in telnet. Let's go back and resend the session, and there you go. We now get a password prompt. Now the password it's asking for me here is the password that we set on the VTY line. So that's going to be Cisco. And then it's put me into the user exec mode. And if I do EN for enable to get into privilege exec, I now prompted for another password, which would be the enable secret password, which again was Cisco. So I'm now logged on telnetted through one tab, console in the other. And you can see actually who's logged on. If I do who, you can see someone's logged on with the console. The star represents me on this tab, and someone's logged on a VTY. If I go over here, I can see I'm logged on to the VTY. So we can see someone's console and VTY'd into this box. So telnetted and locally accessed. So we've done the hostname just before we wiped off the Cisco CP configuration. We looked at the boot process. We looked at the running config and startup config. So just to kind of explain what that means again, if we do dir NVRAM, so this is saying show me the directory of non-volatile RAM, and this is where one of the most important files are located for the Cisco, the startup config. So again, when we go through that boot process, everything you do here, so everything in this show run, will not go into the startup configuration unless you save the configuration. So everything I've done, like for example the VTY and the input and so forth, that's now running in RAM, and if the box were to lose power, I would lose those changes. In order to change it and move it to the startup configuration, I will need to do the copy my running configuration to startup configuration, and then once it's built the configuration and saved it to the NVRAM, when I reboot now, I will have that configuration. Not only can I do show run to see what my current configuration is on the box, I can even do show startup to look at the configuration the Cisco will load next time I reboot the box. And if I go down, you can see my input telnet is there now. If I do dir flash is where the things like VLAN.dat, that's something you'll get into in the CCNA, which is the database for the VLANs. And most importantly, that you need to remember at the CCENT, look at this. This is the iOS image for the box. So remember when it booted up, it was in ROMMON mode, and then it uncompressed an image. Here it is. This is what it basically uncompresses and boots from ROMMON mode, and this is the actual iOS. So if we have multiple iOSs inside this flash, we can specify which one to boot, or it will boot it in an order depending on what you give it, like oldest file or basically alphabetical, whatever it may be. But in the running config, you can specify which one to boot. But again, that's kind of a little bit different. But what we will do in a later video is downgrade and upgrade a Cisco iOS using kind of TFTP, FTP and so forth to make sure you're comfortable with kind of basic flash management and iOS management. So quite a lot of information going on there. I wanted it to be more hands-on rather than having a presentation put in your face. So hopefully that was a little bit different. But just to kind of recap what we've done and then to actually confirm in the presentation what we learned from this actual video. So first of all, we booted up a brand new 887 and it came pre-installed with the Cisco CP. We didn't want to use the Cisco CP, but we had a little investigation of the configuration and we could see it has a VLAN 1 setup with a DHCP pool and a lockdown with an access control list, and it meant that we could browse to the Cisco if we wanted to and set up using the graphical user interface. Well, we changed the username and the host name just because we can, and we didn't want to get timed out while I was making the video. And then we erased the configuration, rebooted the 887, and whilst it was rebooting, we had a look at the boot process. We talked about flash, NVRAM, iOS, startup and running configuration, and we also then had a look at saying no to the initial configuration that comes up. And actually what we've done was pop an IP address on a VLAN, put a port inside that VLAN, and then configured the VT wireline to allow telnet. We then configured the PC to then telnet into the box. So I think it's going to give you a feel of the configuration and what to expect when you unpack a Cisco. Like I said, the Cisco CP is not on all boxes. You're more likely to see the prompt that says, do you want to start the initial configuration? If you want to do that, follow it through, but it's going to take you through 20-30 steps of just continuous configuration questions, and normally after about 5 questions people get frustrated. That's why we cancel it. It's not something you need to be aware of for the CCENT, but it's important to get a feel of what to expect in a real environment. So now, based on all of that information that we've done, I kind of want to take away some key elements, and the focus I want to take away from all of that wasn't the telnet, wasn't the kind of boot process, not to an extent anyway. What I really want to take away is some of the key words that we talked about, or the key phases around the flash, the NVRAM, and those sort of things. The whole point of doing the initial setup and the unboxing was to kind of get us out of this presentation and get us looking at some Ciscos. So some of the things that we need to remember then. So flash, we can look at the flash by doing the dir, which is short for directory, and flash. And like I said, this is kind of like the hard drive of the Cisco. It's where the flash is stored before it's uncompressed. Also, you can store your running config in there. You can have multiple different configurations, and you can upload anything into a Cisco really. It can act like an FTP or TFTP server, but of course the flash is going to be limited on its space. The flash can be expanded depending on the make or model, and you can see that using the Cisco datasheets. The NVRAM, again, that stands for non-volatile RAM, and you can do the dir NVRAM, and this is the important bit. This is where the startup configuration is stored. So when the Cisco boots up, its configuration is saved, and that configuration is called the startup configuration. So not the start configuration, the startup configuration. Now the RAM is where the running configuration is kept. So the running configuration is built every time the box is booted based on the startup configuration. So if it's not in your startup configuration, it won't be imported, if you like, or loaded into the running configuration. So the running configuration is kept in RAM, which means that when we turn the box off, we lose everything in our RAM. So unless we put it into the startup configuration, we won't see that when we reboot. Now, that might seem a bit odd, but that's actually really useful in the real environment, because it means that if we make a mistake and get locked out of a box and there's no way of getting back into it, if we reboot it, it will load up the last startup configuration rather than loading up the running configuration. So there are some real benefits of having that separation between the startup and the running configuration. Just remember the difference between them and remember where they're stored. That's an important bit there. So the startup versus running, so that's what I've just talked about. Startup is what the configuration, once it's saved, becomes, and it's then put into the running configuration, which is stored in the RAM. And it's important to know how you put things from the running configuration to the startup configuration. So what do I mean by that? If I'm making a change, let's say I change an IP address on an interface, and I want to make sure I save that configuration, I need to say copy my running configuration to my startup configuration, and then it will move those changes to the startup. I can see my startup configuration by do show startup, or I can see my actual current running configuration using the show run configuration. Now I've also popped in brackets here, not WR. WR is a legacy way of writing the configuration. And the reason I say not WR, because a lot of engineers tend to say just use WR rather than copy run start. Now you can use it, but it's not the Cisco recommended way, and it's not in the Cisco press books. So if you remember WR and not copy run start, then you may get a question regarding the command copy run start, but not the command WR. So remember it the way that Cisco want you, not the way someone told you to. So what I really want you to take away from the video is have a feel of what comes in a Cisco. We had a look at unboxing one, or at least one that I unboxed previously, and we've seen it had different Ethernet cables, what type of console cable came with it, and we had a physical inspection of that. We then looked at a terminal client. I used secure CRT. We looked at the different settings required and how you would identify the COM port. And then we connected using the console. We looked at what was initially on the 887 and how to erase it, and then going through some configuration changes and how to save those changes and check that they were saved. We then talked about the NVRAM, the RAM and the flash, the difference between the running config and the startup config, just as previously explained. And then we had a brief look at the boot process. We rebooted a box after the configuration was deleted, and we talked about the ROMMON mode very briefly, and we talked about some of the checks it goes through prior to actually uncompressing and installing the running configuration, or at least building the running configuration from the startup configuration. In the next couple of videos, we'll obviously look at the flash management in a bit more detail. How do I upgrade and downgrade an iOS? And some of the other things. So on the Cisco blueprint, it outlines to make sure you understand how to do telnet configuration. So we will actually formally write down the commands required for that and what they actually do. And then we will dive into the other things they want us to know, like how to set the system clock, the time zone, and loopback addresses, and local authentication, all sorts. Thankfully, it's more hands-on. I hope this video has been informative. I'd like to thank you for viewing. And if it has been, please do like and subscribe.